Welcome back to the Deep Dive. This is where we take the source materials you send us, all the articles, the research, the tech reports, and we sharpen our analysis to give you what you absolutely need to know without the overload.
And today, we are diving deep into the electric vehicle revolution. It's a transition that I think everyone agrees is happening. But the reality on the ground, especially when you look at vehicle reliability, it's causing some serious whiplash.
The reports you sent us paint a completely contradictory picture.
Exactly. Our listeners curious about the future, of course, but they're focused on what's a painful and, frankly, a very confusing present. So our mission today is to try and reconcile these two wildly opposing views on EV dependability.
And in doing that, maybe we can get a handle on the true state of the global EV market.
Right. How can two equally reputable organizations look at pretty similar data and come away with conclusions that are just polar opposites?
That's the core of it, isn't it? On one side, you have Consumer Reports, or CR, in the U.S. Their data finds that EVs and plug-in hybrids, PHEVs, have 80% more issues than conventional gas cars.
80%? That sounds like a disaster.
It does. But then you flip over to the data from Germany, ADAC, which is the largest roadside assistance service in the country.
It's huge.
Huge. They analyzed millions of breakdowns and found the complete opposite. They found that EVs have significantly fewer issues.
For models from 2020 to 2022, they're logging, 4.2 breakdowns per 1,000 EVs?
Compared to 10.4 for internal combustion engines,
That's more than double the failure rate for a gas car.
The difference is staggering. So let's unpack this paradox. Is it growing pains or is it simpler design? It seems to really depend on when and where the data was collected, which, it speaks volumes about the maturity of the tech.
Let's start with that alarm bell from the U.S. from Consumer Reports. When their analysts, folks like Jake Fisher and Stephen Elek, looked at their data, they framed these EV issues as growing pains. What did they actually mean by that?
They mean that reliability issues almost always pop up when an automaker introduces a brand new platform or a really aggressive redesign. You're moving away from a fully amortized ICE engine that they've been perfecting for decades.
Right, something they know inside and out.
Exactly. And you switch to a new electric drivetrain, a new wiring harness, all new software. You're introducing a ton of new variables that just haven't been road tested for 5 or 10 years. That initial friction, those design kinks, that's what CR is capturing.
that makes a lot of sense, especially when you look at this specific group that did the worst in their study. You mentioned that the absolute lowest score went to plug-in hybrids, the PHEVs.
Oh, they were the worst offenders.
I mean, by a huge margin.
Oh, huge.
The CR data found PHEVs had nearly 150% more problems than conventional cars.
Wow. 150. If the gap is that dramatic, shouldn't automakers just abandon the whole PHEV concept? Is there any reason that complexity is justifiable?
Well, it's justified by transition logistics, not mechanical simplicity. A PHEV is a bridge. It's for drivers who, need electric range for your short commutes, but they want the security of a gas engine for a long trip, or if charging is unreliable.
The best of both worlds, in theory.
In theory, but mechanically, it's the worst of both worlds. You're not just carrying the fluids and pistons and gearbox of an ICE vehicle, you're adding an entire high-voltage battery system, special chargers, and all the complex software
To manage the handover between the two.
So you double the complexity, you more than double the failure points. That's the new tech teething the CR data is seeing.
Precisely. Now you contrast that
That was what the ADAC data in Germany is capturing. They looked at 3.6 million breakdowns, focusing on pure EVs, which, once the platform is established, they have a very clear mechanical advantage.
And the argument is just so simple. Fewer moving parts means less can go wrong. No engine, no transmission, no oil systems, no exhaust.
Right. ADAC concluded that for these modern EVs in their early to midlife, that a sheer reduction in mechanical complexity translates directly into dependability.
So if we synthesize this, the key takeaway is that the contradiction isn't really a flaw in the data.
Not at all. It's a function of maturity. CR is capturing the pain of first and second gen EV designs and these overly complex PHEVs, while ADAC is showing us the long-term reliability that kicks in once those initial kinks get worked out.
Okay, that gives us
The context we need. Let's drill down now into some specific faults, because some problems seem to pop up no matter the powertrain. And the biggest irony here is it's in the most humble component
in the car.
We have to talk about the 12-volt battery.
The little standard battery that runs the lights and the radio. Even when you have this massive revolutionary high voltage pack under the floor.
Exactly. It is the #1 cause of roadside failures for both EVs and for ICE cars. EV callouts and 45% of IC callouts.
So why can't the massive battery just take over if the little one dies? That seems like such an obvious design flaw.
It's a systemic limitation. The high-voltage battery is designed to propel the car, but the 12-volt system is essential for the, let's call it the initial boot sequence.
Okay.
It powers the low-voltage computers and the relays that literally tell the massive battery pack, hey, it's safe to turn on. If that little 12-volt battery is dead, the car can't wake up. It doesn't matter how much charge you have in the main pack. It's
The weakest link.
That is a potent irony, a century of innovation, and we're still stalled by the same $100 part. So beyond the 12-volt, what other EV-specific issues
Were CR members reporting?
well, looking at the new architecture, people reported troubles with the high-voltage battery itself, with the charging systems, and crucially with manufacturing quality.
Ah, the fit and finish problem.
Exactly. Panel gaps, poor interior trim. This points right back to that growing pains argument. The process of just putting these cars together efficiently is still maturing.
And there was also a slight mechanical issue. That's a direct result of EV architecture, wasn't there? Tires.
Yes, the ADAC data showed EVs had about 45% more tire-related callouts. This is almost certainly because of two things. One, the extra weight from those heavy battery packs, and two, the incredible instant torque that EVs deliver.
It just shreds the rubber.
It puts immense stress on it, but it is important to note the sources say this is getting better in newer models. Tire makers and engineers are adapting.
Okay, before we move on to the geopolitical race, let's just quickly revisit the hybrid success story. We slam PHEVs for being too complex, but CR found standard non-plug-in hybrids are a huge win.
A significant boon was the term they used. Standard hybrids, which don't require external charging, have 15% fewer problems than pure gas cars. Automakers have had 2 decades to perfect that system. It shows that reliable electrification is absolutely possible once the design matures.
And you see that refinement in the CR brand reliability scorecard. The brand's known for slow, steady, iterative improvement. Subaru, BMW, Porsche, Honda, Toyota, they dominate the top 5.
And this is where we see the maturation happening in real time, especially with Tesla. They actually made the top 10 for the first time.
10th place, right?
10th place, which is not trivial. CR analysts said it's because of improved build quality and reliability in their established models, the updated Model 3 and Model Y. The brand is starting to escape that old reputation for inconsistent quality.
So the Model Y, despite all that history, was ranked as the most reliable EV in its segment. That's a huge endorsement for maturation.
It is. But let's look at the flip side, which is the Rivian paradox. This is fascinating. The Rivian R1T ranked lowest in the EV segment for reliability.
Okay, lowest.
Yet Rivian scored
Highest on owner satisfaction.
Wait. That's genuinely confusing. How are owners with reliability problems so happy?
It's a classic sociological thing. CR analysts point out that early adopters are often risk takers. They aren't buying an R1T for mechanical perfection. They're buying it for the experience, the performance, the image of owning something brand new.
So they're willing to overlook the flaws.
They're willing to overlook the first-generation manufacturing flaws, bad panel gap or a software glitch, because the overall experience is so exciting. They're evangelists, not, your typical mass-market consumer yet.
That really helps put the data into perspective. Okay, so knowing these technical weaknesses and the immense pressure to fix them, let's zoom out now, because this is where it gets really interesting. We need to look at the global race for EV dominance.
Yes, specifically the intense pressure
Europe is facing from China.
The competitive challenge seems enormous. The sources we looked at suggest that despite Europe investing, 250 billion euros?
A massive number.
They're
Still considered years behind China in the EV race. Why is that happening? Europe has the engineering history, they have the capital. Why are they so slow?
It boils down to structural resistance and manufacturing legacy. European governments have been trying to manage a slower, more deliberate transition.
Why?
To protect the big traditional automakers. Many of them still rely on their highly profitable ICE production lines for their cash flow. They need the transition to be gradual to maximize those legacy profits.
So they're prioritizing a smooth societal transition over a rapid revolutionary one.
Exactly, and the sources are very critical of this. Many European legacy makers were too slow to develop dedicated EV platforms. Instead, they opted to shoehorn electric power
Systems into existing ICE platforms.
Can you explain what shoehorning means in this context and why it's so bad?
When you shoehorn, you're cramming a new system into a structure that was designed for a combustion engine.
This compromises everything. You get poor battery packaging, clean sheet of paper backed by huge government support over a decade ago.
And their primary strength now is vertical integration.
Full vertical integration. They don't just control the raw lithium, they control the refining, the production of power electronics, the battery chemistries. This end-to-end control gives them unmatched speed, flexibility, and most importantly, price control.
And that price disparity is staggering. We saw examples of major European brands selling their EVs for so much less in China.
Look at the VW ID.3 and ID.4.
In China, with subsidies, you could get one for around $25,000. In Europe, a similar spec was closer to 45,000 euros.
Nearly double. That kind of pressure
From cheaper Chinese rivals threatens the entire profitability model for Western automakers.
It absolutely does. It forces every automaker to make these agonizing decisions about where to manufacture and what components they can afford. But it's not just a race to the bottom on price. There's a big technology debate, too.
Is China's tech lead universally accepted, or is it a bit more nuanced than that?
Oh, it's definitely complex. Some sources claim Chinese EVs are ahead, pointing out that high-end models often include advanced hardware like LiDAR as standard. That suggests a strong software lead.
But the Europeans push back on that.
They do. Premium European brands, especially your BMWs, Porsches, Mercedes, they argue their latest models are superior in areas that are critical to the driver, like overall efficiency and real-world range.
So it's a trade-off. Price and advanced hardware versus refinement and established quality.
Precisely. And we should also recognize the brands that are succeeding quietly outside of this big Europe-China conflict. Korean brands like Hyundai and Kia, and certain European
Models like the Renault or the Fiat 500e are showing excellent reliability in that ADAC data.
2 to 4 falls per thousand vehicles, right?
Incredibly low numbers, and they back it up with strong warranties, typically 8 years or 160,000 kilometers on the battery, which is a huge confidence booster.
And what about safety? That's still paramount for everyone.
The scores are very strong across the board, which is great to see. In the latest Euro NCAP tests, the Tesla Model Y led the pack, especially in driver assist systems. But significantly, many Chinese brands like the BYD Seal and Dolphin are also getting top 5-star ratings. They are absolutely matching the established players on safety.
This has been a really comprehensive deep dive. So reliability in the EV world is, well, it's not a simple yes or no question. It's a really complex picture that's influenced by, it seems,
3 things. Vehicle maturity,
That's the CR versus ADC conflict.
component choice,
The humble 12-volt battery being the biggest headache.
and manufacturing approach.
Yeah.
legacy compromise versus a dedicated, vertically integrated platform.
And that manufacturing approach, coupled with geopolitics, that's the long-term game changer. EVs will, without a doubt, get more dependable as the tech matures. Tesla's climb in the rankings proves that. But the competitive pressure, driven by China's integrated approach, forces every other automaker to constantly rethink everything.
It fundamentally changes what an engineering success story even is in transportation.
It does. I mean, think about it. If the greatest advantage for traditional automakers was perfecting the immense complexity of the internal combustion engine,
All those moving parts.
right, then the mechanical simplicity of the EV fundamentally shifts the competitive edge. It moves away from those who mastered the gearbox and towards those who can master the battery, the supply chain, and the software.
And that raises a really important question for you, the learner, to think about. What does this shift mean for the very idea of a premium car?
When new players dominate the software and the traditional signs of engineering perfection like a silky smooth V8 are just gone, what's the new definition of luxury or performance?
Is all the value now just in the interface and the electronics, or does